It's that time of year again, and I want you to be successful. Alright, you guys, as I said before, it is that time of year again. We have end of the year exams, ELCs, STAAR tests, FSAs, you name it, whatever abbreviation test you are taking. I want you to comment it in the comment section, and whatever problem you may need help with, go ahead and drop it in the comments or send it to the Math by Isaac Instagram. As requested by one of the viewers, the Math by Isaac fam has selected exponential functions. One of the viewers asked if I could do a video on that, and here we are today. So remember guys, send in your questions and your concerns, and we'll try and solve it here on Math by Isaac. Let's get into it. Alright guys, let's get started. So here is a prime example of what an exponential function looks like. It starts off flat, or assuming to be flat, and I'll go into further detail about that later, but for now it just looks flat, and then it slowly starts to arise. So that's what we like to call an exponential function. It's a function that slowly rises, and it can also slowly decay. So let's also look into it at that nature. And here we also have three different types of equations when it comes to exponential functions. As you guys are familiar with, we have our familiar variables, but now they are in a different format, which I'll go into later. So the first equation we have is y equals b raised to the x power. Y is equal to a times b raised to the x power. Y is equal to a times b raised to the x power minus h, and then plus k. Now don't worry, it looks hard, but I guarantee you it is similar to most of the functions that you already know. Alright guys, let's start off with the basics. Here we have our asymptote as well as the inflection point. What is the asymptote? It's basically the limit to which your y values can reach. So our exponential function will never cross the asymptote. Even though it looks like it's literally right on top of each other, it will never cross it. So our asymptote could be y is equal to 5, but our exponential function can go all the way as to 5.00000012, but it will never cross 5. So that's basically what an asymptote is. It is the limit to which your y values can reach. Now our inflection point, which is represented by this green dot, is basically going to be our takeoff point. So here we start off slow, we start off flat, but as we keep going, it slowly starts to rise. Out of nowhere, it catches up and just takes off. Kind of like an airplane. You start off, then all of a sudden it gets to one speed and it takes off. An inflection point is basically your takeoff point. Alright guys, let's go ahead and get started with looking at our variables as to what they do in an exponential function. Now if you haven't watched the STAAR test video I did on functions, I highly suggest you do so, as it will help with what we're going to do today. Now for those of you that watched it, we already know that a, b, x, h, and k, these are the variables we use to move our function everywhere, whether it's flipping our function over the x-axis, whether it's moving it to the right or to the left 5 units. These are our variables that help us modify our parent function. However, in an exponential function, some of these variables move and work differently. So let's go ahead and talk about that. So here we have b, which is our base. B is going to be our number that's greater than 1, not greater than or equal to, but greater than 1, but it can't be 0. B helps us see how steep our graph is going to be. So for example, let's say we have our b being 8. So we have y is equal to 8 raised to the x. So our function is probably going to go from here, slowly up. However, if we have a b value that is, bigger than 8, so it's, let's say, how about we try 20? Make that neater. So the bigger your b value, the steeper it's going to get. So let's say we have 20. Our exponential function is gonna go right up, sort of like a 90-degree angle, if you know what I mean. So the bigger your b value, the steeper your function is going to get. So always keep that in mind when you're looking at questions they give you on these end of year exams. Another thing about the b is that if it's negative, it flips over the asymptote. So remember what I said about the asymptote. It's that limit for our y values. So let's say we have our asymptote right here, and we have our exponential function. Let me make that a bit neater. So our exponential function is gonna go up. However, if our b value is negative, it's going to flip over, giving us a different exponential function. So it's going to be flipped over the asymptote. So that's one of the other functions our negative b, has on our exponential function. Next, we have what happens if our b is greater than 0 but less than 1. So, in different equations or in different types of quadratic functions, we see b doing other things. But here, however, it's going to flip over our inflection point. Remember our inflection point. So here we're going to take our exponential function, and here's our inflection point. So rather than flipping it over our asymptote, if basically our b is a fraction, or greater than 0 but less than 1, it's going to flip over this inflection point. So we're going to take it, it's going to flip over. So it's going to go here. So it's no longer going to be going up. So it's rather going to be what I like to call a decay. So it's going from a higher position to a smaller position. This is what I like to call a decay. So if your b value is going to be a fraction or a decimal, notice that it is going to get a decay. It's going to flip over that inflection point. All right, guys, next on our list of variables, we have a. So here, if a is greater than 0, it's going to move the exponential function to the left. So you could see this because the inflection point will always move to the left with the exponential function. Now, if a is greater than 0 but less than 1, it moves to the right. So it's going to go ahead and move the exponential function or the inflection point to the right. So let's say if a was, for instance, 0.5 or 1 over 8, it's going to move the exponential function to the right. Now, what if a is negative? If a is negative, it's going to flip the exponential function over the asymptote. So wherever the asymptote is, it's going to go ahead and flip that function over the asymptote. All right, guys, last on our variable list, we have h and k. Now, to all of you, this is no surprise. H and k is going to be on almost every function that you face. H basically controls horizontal movement. So it controls how many units to the left a function moves or how many units to the right a function moves. Now remember, it always moves opposite of the sign. That's because you see here that h is negative. So if you have a negative h, so let's say h is going to be represented as -5. So the function is going to move not -5 units to, the negative side. It's going to move 5 units to the positive side. H always moves in opposition of the natural order. However, if you have K moves vertically. K controls the vertical movement. So K is going to move up 5 units, down 5 units, and it actually goes to the natural sign. So if K, for instance, is going to be +5, it'll move up 5 units. And likewise, if it's -5, it'll move down 5 units. Alright guys, now that we have looking at exponential functions as to how they work, let's go ahead and do some sample problems. For these sample problems, they'll be put in the description. And if you want to find them on the internet, just go to your internet browser, type up STAAR test release questions or Florida statewide assessment release questions, and you should be able to find some Algebra 1 questions or questions of any subject there. Here we're looking at the STAAR test for Algebra 1 2018. This is question 23. It says, what appears to be the domain of the part of the exponential function graphed on the grid? So here we have an exponential function and we're asked to find the domain. So what is the domain? The domain, as we should all remember, is going to be your x values. So we're looking for values of x. Where do they start? Where do they end? Domain will always be in x. So right off the bat, we could go ahead and eliminate b as well as d because they have y values. We're looking for x values. So let's go ahead and look for where x starts. So here we have a -1, starts at -1, and we end at 3. Through this span, we see that x values go from -1 to 3. So x is going to be greater than or equal to -1. So this is including -1. And it's going to be less than or equal to 3. So this is also including 3 whenever you see less than or equal to. So therefore we can conclude that A is the correct answer. If we go to the answer key, go to question 23, we see that A is indeed the answer. Now, why did they put C? C is not the correct answer, but at times I'm curious. So we see that it's not C because we see it's 5.3. Now 5.3 is around the 6 area, and 27 is up here. So we know that they were looking for y values, it's just that they replaced y with x. So the correct answer for question 23 is going to be A. Let's move on to the next question. This is a FSA Algebra 1 practice question. Here it says, the function f of x models the value of goods that are imported into the United States. So f of x, so everything here, are imports into the United States, where x is the number of years since 1990. So these are all the years since 1990. Now it says the function g of x models the value of goods that are exported from the United States. So these are all of the United States exports. If f of x and g of x continue to model, if f of x and g of x continue to model the importing and exporting of goods, then sometime in 2041, which is 51 years after 1990, f of x should equal g of x. So they're saying sometime around the 51 years after 1990, we should see that f of x and g of x would be equal. So notice, sometime around there. So we see that sometime around this time, f of x and g of x will be equal. So it says determine which function is exponential. Use the table of values to justify your choice. Type the answer in the space provided below. And below we have the answer, but we're not going to get there just yet. So we see that the question is asking us to determine which function is exponential. So let's go ahead and think. What are the values of exponential functions? What do we know about exponential functions? Well, for one common thing that that separates it from the rest of the functions is we have that takeoff point I mentioned earlier. So the function gradually goes up, but it still looks like a flat line, and at one point, which is the inflection point, it just takes off, it goes up. So we're gonna see our values being close, and then all of a sudden you're gonna see a spike. So let's see if we can find that here. So let's go ahead and look in f of x. So here in f of x, we're going from around 8.8 million to 10.3 million to 11.8 million to 12.1 million to 12.4 million to 13.4 to 15.1. So nothing out of the ordinary. It looks like it's going up in increments, either of 2 million or 1 million, or somewhere in between that range. Let's take a look at g of x. Here we have 6.2 million followed by 8.4 million, 11.4, 12.1, 12.8. Then we get to 15.3. Then we get to 20.6. So we see that starting from around the first 4 values, it's nothing out of the ordinary. They're going up in increments, but as we get to the last 2, we see something huge. They spike up in terms of value. So we go from 12 million to 15 million to all of a sudden 20 million. So here from 12 million to 15 million, that's about a $3 million jump. From 15 million to 20 million, that's about a $5 million jump. So we see an increase of value quickly. So it says determine which function is exponential, and based off of what we have here, we can go ahead and say that g of x is going to be an exponential value. And if we go to the answer, it says the amount of exports will exceed the amount of imports because exponential functions grow faster than polynomial functions. Remember, I said that exponential functions, out of nowhere, they just jump up. So we already knew that g of x, which is the exports, will exceed. So we know that when we're asked the question, determine which function is exponential, we can boldly say g of x. And also, if we look at the other correct responses, we see that it says here the exponential function is the amount of exports, because the values for the amount of imports, which is being represented as f of x, are approximately linear. What does that mean? It means they're moving up in increments. So it's something, planned. So, okay, after every year we're moving up 2 million. After every year we're moving up 2 million, and thereabouts. So something that is staged, something that is set. If we look at the other correct response, we see when x is less than 51, the values of exports are less than the values of imports. When x is greater than 51, the value of the exports are greater than the value of the imports. Therefore, the function that represents exports is the exponential function, because an exponential function will eventually exceed a polynomial function. And this is true, because if we go to Desmos, by the way, if you need any free graphing, always go to Desmos. That's what I use. So here we have 8x. So this right here is our exponential function. So you have y is equal to 8 raised to the x, which is represented in blue. So this is our original function right here. Now we have our polynomial function, which is y is equal just to 8x. So let's say the black represents our imports, and our blue represents our exports. So remember, we said our exports, which is represented in blue, is going to exceed that of the imports, which is represented in black. And we could test this using using one of these values, x is equal to 3. And if we zoom out, so we see that when x is equal to 3, our imports are equal to 24. So this shows that our imports get there faster, but are they more? No, because if we zoom out actually, and we look for where our imports get to, where our exports connect with 3. Keep scrolling, keep scrolling, keep scrolling. We see over here that when x is 3, our exports are 512. So even though it took a long time to get there, even though it took a long time developing, we still see that our exports, which is represented in blue, will always exceed our imports, which is represented in black. Or in mathematical terms, our exponential function will always beat our linear or polynomial function. So that explains question number 10. Now let's go ahead and move on to our next question. Here we have question 9. It says an exponential function is graphed on the grid. Which function is best represented by the graph? So how can we break this down? So we're asked to find a function that is represented by this graph. Which function is going to be the same as this graph when you graph it? So we're looking for a function, but how do we know which function is represented in this graph? Well, we have to look for tips and tricks. So one thing I highly advise you to do is to always play around in Desmos. Right before or when you're learning anything about graphing, play around in Desmos. Look for interesting facts. Look for loopholes that you can find in any type of function. So while playing around in Desmos, I was able to see that when your function is just an AB function, if you don't understand that, you might want to rewind the video. But when your function is an AB function, meaning you have an A and a B, then your exponent, which is x, your A is always going to be your y-intercept. So our a, which is 6, here we see it 0, 6. That's our y-intercept. So for one thing, we're going to have to know that our a is going to be 6, which is represented all around here. Now let's look at another, let's dissect this graph. Now this isn't a growth graph, it's a decay, because we're starting up high and we're coming down low. So one thing we need to know about this is that our b is going to be greater than 0 but less than 1. So our b is going to be a fraction. So right off the bat, we can eliminate d and we can eliminate b, leaving us with two options. Now, if you're stuck in this situation without a graphing calculator, which is highly unlikely, but if that were the case, you would have to make a 50-50 guess. In this case, I would have chosen A, because look at this, you have a minus right there. If there's a minus, our graph is going to be flipped around. So we can eliminate C. So not even a guess, so you would know that your answer is A. But just to be sure, if you have a graphing calculator during the exam, you could go ahead and type this in. So y is equal to 6, and you have 1 divided by 3 raised to the x power, right here, raised to the x power. As you can see, this is very similar to the graph we have here. See, it crosses 6 right there, which is our y-intercept. And just around the 3, 4 area, see it getting closer to the graph. So therefore, I would have picked A. Now if you're wondering why I put y instead of g of x, whenever you have g of x or y of x or anything of x, it doesn't necessarily mean that it's different. It's just the same as saying y is equal to. So just a side note. And if we look at the answer key for this is question 9, the 2019 release STAAR. Go to question number 9. We'll see that the answer is indeed A. So A would be the correct answer for this type of question. Let's move on to the next question. Here we have question number 31. Same test, 2019 Algebra 1 STAAR. Again, link in the description. So it says the table represents some points on the graph of an exponential function. So which of these functions represents the same relationship? So we see function, we see relationship, we see represents. In simple and easy terms, if you never understand the question, try and break it down. All it's asking for is which function will give us these numbers. That's the simplest you can go. So we're looking for which function here is going to give us these numbers. So let's recall what we know about exponential function. Well, remember guys, use what you know. We already know we have an a-b function here. So what's one thing I just said about a-b functions? Your a is always going to be your y-intercept. Your y-intercept is where x is equal to 0, and we see here that our y-intercept is at 18. So right off the bat, don't waste time graphing these into the calculator. You could go ahead and eliminate a, and you can eliminate c, giving us two answer choices. Easy, very easy. So even if you are stressed out with time, these type of tricks help you save time. So you have 18 times 6 over 5 raised to the x, and 18 times 5 over 6 raised to the x. Now which one of these will give us the answer? Now in case you don't have a graphing calculator, again, which is highly unlikely, another way you could solve this is by inputting your x values into the equation. So let's go ahead and try that. So we have 6 over 5 and 5 over 6. So more than likely, we just need to add one type of x value into our exponent, and that should give us a difference. So let's go ahead and let's try 1. So remember, 18 times 6 over 5 raised to the first power. So we have, let's start with 6 over 5. Now we're going to raise it to the 1 power, which is itself, and times 18 gives us 21.6. Here we have 21.6. So right off the bat, we could go ahead and go B. But remember guys, you never just want to jump the question. If you have another reasonable answer choice, also go for it as well, as it could be correct. So let's try that. So 5 over 6, I'll give us that, raised to the first power, give it itself, then times 18, that will give us 15. Notice 15 is not what we're looking for. We're looking for when x is 1, y should be equal to 21.6. So therefore we can conclude that B is our correct answer choice. And if we go to the answer key, question number 31, you see that indeed the answer is B. So we know that our answer is B. Now for our final question, easy question, just looking for the domain, nothing out of the ordinary. So our domain in this case is going to be our x values. So what did I tell you about domain? X values. So B is not it, D is not it. Go ahead and scratch those two answers out, because that's not what we're looking for. We have a -2. Always look for domain on the x-axis. -2. But notice the graph, notice the function as an arrow at the top. So it's going to keep going. This isn't a function. Remember the last one. In our first one, we just had two lines, a starting and an end point. But in this one here, we have a starting but no end point. It keeps going. So we're not going to have something is less than or equal to x, which is less than or equal to another number. We're going to have x is greater than or equal to a number, or less than or equal to a number, leaving us with A and C. We see a -2, -2. That's all you need to do. Now, why did they give us this? We can go ahead and eliminate this answer choice, because look at this. 4.5 is right in between 4 and 5, which are y values, meaning they just gave us a y value in a x, in a x inequality, which is totally wrong. So B, C, and D are incorrect, leaving us with A. So A is going to be our final answer choice. And if we go to the answer key once again, go to question number 41, we see that A is the answer. Alright guys, that is the end of the video. I really hope you learned something. Remember, if you have any questions, don't forget to leave them in the comment section or DM me on the Math by Isaac Instagram page, and I'll be sure to respond. Make sure you guys like the video, comment, subscribe. You guys know what to do. And that's it for today's video, guys. Stay safe and God bless.